Critical values are a specific point along a statistical distribution that acts as a cutoff point or a boundary between regions. We're going to be working with alpha, and alpha represents the area to the right of that critical value. And since the area under the curve is equal to 1, if we subtract alpha from 1, that gives us to the area to the left of the critical value. Critical values are always going to be rounded to 3 decimals. Let's look at this area under the curve to find the critical value of z.15. The 0.15 indicates our value of alpha. Because we're working with z-scores, we are going to label our mean as 0 and our standard deviation as 1 directly in the center of our normal distribution. We then need to think about the entire area under the curve as 100% and figure out what is the value of 0.15 in relationship to the entire area under the curve. Since 0.15 is the area to the right of this critical value, that means z of 0.15 lies over here somewhere to the right of our mean and our standard deviation. If we think then again about the area under the curve being 1 and 0.15 as being only about 15%, you can see that I've sectioned off my graph to where I have here about 50%, 75%, and this is about 85%, leaving the other 15% in this smaller section. That means that alpha lies in the right tail of this shaded area seen here. That means the cumulative area to the left of that critical value is 1 minus alpha, or the other 85%, 0.85, to the left of that critical value. When working with z-scores, such as z of 0.15, remember that that value that is there to the right is a subscript, again representing the area to the right of the z-score I am trying to find. I will then do that using the INV norm feature with a 0.85, or area to the left of the z-score I'm trying to find, and again my mean and standard deviation of 0 and 1. Notice that what I have written on my paper does not include the words left, right, or center, but on my calculator, because I have that option, it will show me what I've chosen. When you write this down on your paper to show me for my class, you're going to write only INV norm. We're going to assume you're always going to write area to the left, the mean and standard deviation, and then you're going to end your parentheses. You will only be including these 3 values in your work submission. Since we are working specifically with a critical value, and our rounding rule is 3 decimals, rounding this we get 1.036. Notice that when I approximated the value of about 15%, or area to the right of a z-score, I put that line somewhere between 1 and 2. So when I eyeballed or visually put where was that value going to lie, I came up with a pretty good idea of where that is, because 1.036 is somewhere between 1 and 2, closer to 1 than 2, and that's about where I put that at. You want to make sure that when you are identifying the z value or the x value, that you try to get as close to accurate as possible of where you're going to put that line. You don't want to just put it somewhere random where it doesn't look like the actual area or value that it represents underneath the curve. So with 0.15, you wouldn't want to put it right here in the middle where it represents a 50%. And you wouldn't want to put it way down here where it would only look like it represents 5%. So try to be very neat and organized and think about specifically what are the areas that these decimals represent, so that way you can give a more accurate representation of the value along the number line you're trying to find. And then visually you can kind of do a little check to make sure that the number you came up with is about approximately a good idea of what you should have come up with.